welcome to the ATP Project. You with your hosts, Steve and Matt, the handsome, smart, good-looking ones, and Jeff just didn't cut it today because he wasn't handsome, smart, and good-looking enough. No. Today's podcast is the oxygen paradox. And today we're talking about antioxidants and pro-oxidants. We obviously know we need oxygen. We're going to talk about how our body regulates our oxygen, talk about how our lungs regulate gas exchange, how our stomach doesn't. We're going to talk about some of the products that are out on the market that people have been asking us for about how to enhance oxygenation. We're going to talk about when you want a pro-oxidant, when you don't, when you want an antioxidant, when you don't. And we'll give a bit of a summary on how the vitamin antioxidants work, how the herbs and how the foods. And I hope you're ready for all this, Steve, because I'm just telling everyone all the stuff you're going to tell us.
Miles of paper here. I'm going to go nuts.
No, we've got heaps of cool data.
Yeah.
There is a lot of data on this particular topic. So we'll try to make sure you understand the most important parts of it, which is when oxygen's good, when it's bad, why we have these things called antioxidants.
Yes.
And give a really good perspective. And as usual, you'll pick up a bit of a theme that nature knows best, and you can get too much of a good thing. Yeah. But it's more of a point just understanding what the hell you're doing.
Right.
So let's get started, Steve.
Okay.
The first thing I wanted to talk about is we'll go through the most basic things, which is the vitamins. So we'll talk about some vitamin antioxidants.
So ACE, those sort of ones?
Pretty much ACE, yeah. Okay. We'll talk about those. They're the main ones that we will talk about. But the reason why we need to discuss them in depth is because there's quite a bit of conflicting data. So we have lots of good data showing that these dietary antioxidants can protect us and make us live longer and that sort of stuff. But then when they try to create it into a supplement, when they try to take it to the next level and prevent diseases or treat diseases with these antioxidants, things go bad. And then it gets in the news that these antioxidants don't protect us, that our multivitamins might be killing us.
Yep.
So I want to explain to people why that's happening, how that's happening, what the scenario behind it is, and what to look for on a label and that sort of stuff. If it has a label, it's probably one of the hints.
Yes, absolutely.
Look for the label first, because a lot of our fruit and vegetables, which have the nice natural mix of vitamins and minerals, don't typically have labels.
No, they don't have labels. Some bananas have those little stickers on it, the made in Puerto Rico stickers and that sort of thing.
You're buying your bananas. What the hell are you doing, Steve?
I don't eat bananas.
No, Australian farmers.
Although your bananas are nice.
Thank you, Steve.
Yeah, they were good ones.
It's already gone weird talking about eating my banana. But no, but I got those little thin skin sugar bananas.
It was thin
They're like
skin.
little lollies.
Yeah,
it's very thin skin. No, I'm serious.
It's got the red pen out. It's
they're the short little thin skinned Asian bananas.
John was
yellow, you know, the little thin skinned yellow bananas that's particularly small.
Yeah.
That's what we grow at home. That's what I have. My wife loves them.
She loves your short banana.
Well, she's half Vietnamese.
Right.
So she's kind of used to them. Grew up with small Asian bananas.
Yeah, that's problematic.
So, wow. Phew. Now, what the hell are we talking about bananas for?
I don't know.
The most important thing to talk about is vitamins. What we discovered with vitamins. A while ago, we discovered these vitamin deficiencies. And that caused all sorts of problems because we needed vitamins. They were essential. We couldn't make them. We had to put them in. So then what we started doing is measuring or looking at our foods or trying to make sure we're getting adequate amount of vitamins. Unfortunately, because of the farming processes, all this stuff we've talked about multiple times, bad farming practices, poor storage techniques, picking the bloody things green, gas ripening, all this sort of stuff, we don't have the same levels of vitamins in our foods.
Right.
That led to a phase over the last 50 years of synthetic vitamins and fortification of foods and that sort of stuff with all these sort of things. So what we're seeing now is we've got lots of data showing natural variety of all different types of these antioxidants and a natural balance between the vitamins and the forms of the vitamins have a protective antioxidant effect that make you live longer. Well, like we all know eating fruit and vegetables and that sort of stuff is good for us.
Of course it is.
And it'll make you live longer compared to the people that don't eat it.
Yeah.
We've also now got a heap of data showing when someone synthetically creates a version or one form of those and then supplements with that. So let's talk a little bit about that, because there's this vitamin paradox podcast we did once before where we talked about how overdosing of vitamins may actually contribute to death. That might actually make things much worse for you.
It does.
And there's a variety of mechanisms for that. But let's talk about, what do you want to start with, Steve?
Well, I can start with this beautiful first paper from the Cochrane database review, which is a quite a big study.
Move straight on from the bananas to the Cochrane reviews.
Yes, we have to start reviewing Cochrane's and get off bananas. So this was the Cochrane database review, and it showed that back in 2012, and what they did was they looked at all these studies based on antioxidants, and there was about 70-something of them, and basically they found that you've got a 4% extra chance of dying if you take antioxidants.
Yeah, so now, let's talk about the antioxidants.
Yeah, now that's the key. So you should start having fruit and vegetables? Absolutely not. This was vitamin A, or beta-carotene A, C, and E, and this was versus placebo.
Don't even have to beat around the bush now. Was it vitamin A?
Well,
or was it beta-carotene?
They picked beta-carotene and vitamin A and vitamin C and vitamin E, and they looked at these. There were 78 trials on either or all of those, and they combined the results. Basically, you were 1.04 times as likely to die as you were from not taking them. So it slightly increased your death rate. Was it significant? Yes, that's significant for that amount of data. So it slightly shortens your life taking these synthetic vitamins.
And especially, well, it's definitely significant considering they would have surely expected the opposite result.
Yeah.
They would have expected a preventative effect.
Yeah, a preventative effect would have been 0.9
but not
or
aggravated effect. So just quickly, when we talk about vitamin A, just for those that don't know, they come in two forms really.
They do.
Got your pro-vitamin A, and they're your things like your beta-carotenes, your alpha-carotenes, lots of different carotenes. Carotenoids.
Yes.
And they convert it into vitamin A into the body, which we look at.
Zinc-dependent enzyme, absolutely.
Yeah. Then we've got the preformed vitamin A, which typically comes from animals that already ate those other things.
Cod liver oil is a classic one.
So typically an animal that's eating the pro-vitamin A stuff makes vitamin A in their body, and it's found in their tissues because it's fat soluble.
Fat soluble.
So then when we eat those foods, typically oily foods, like you're saying,
Livers
cod liver oils and that sort of stuff, and dairy and whatever, then we get the preformed vitamin A.
Yeah.
Outside of that, we have these other carotenoids that don't actually convert to vitamin A.
That's right.
Lycopene, lutein, astaxanthin,
zeaxanthin, all those, all the
xanthans and all those sort of things.
Yes.
So what we're looking at in nature, when we talk about these dark leafy vegetables, when we talk about these colourful foods and that sort of stuff that contain a big variety of carotenoids, like lycopene's the bit that makes tomato paste or tomatoes red and watermelon red and that sort of stuff. So when we talk about nature sources of vitamin A and carotenoids, there are so many. So in these studies, what they've done is they've taken out vitamin A exclusively without the others, or beta-carotene as a precursor to vitamin A, and they've taken those and not the others. And then what we've found is a weird effect.
A weird effect, or actually a predictable effect, because you've got to remember, we've got to explain what an antioxidant is.
Yeah, do that. That's where we should start.
What oxidation is. And oxidation is the loss of an electron.
Yep.
Oil rig oxidation is loss. It's a few other things. It's a gain of oxygen, loss of hydrogen, but basically it's a loss of an electron. Now, you've heard of a term free radical.
Yes.
Okay, they're a little young student from Sydney Uni, or they are a chemical that has an electron that's really reactive, really reactive single electron. Normally electrons are in pairs.
Yeah.
Okay, they're joined up like sodium chloride.
Yeah.
Sodium donates one electron to chlorine and it's formed stable. It's salt stable.
Yep.
You can burn it, it doesn't burn.
Yep.
But a single electron is very, very unstable. If you think of sodium and potassium, if they're pure in their pure form, you throw them in water, they explode. That's how reactive they are. Don't try that at home, kids. So basically, it's an unpaired electron. So it basically just targets any nearby tissue, which could be a DNA, a deoxyribose nucleic acid thing, which of course damages your genes, or it could be anything else and it causes damage to cells and this sort of thing. Now, what an antioxidant does is it says, I'll have your electron, and it kind of goes and turns into quite... It gets sick, but it doesn't actually go on and cause a massive reaction down the track.
Yeah, right.
So it's sort of, and then there's terminal antioxidants.
Takes one for the team.
It takes one for the team and turns itself into a pro-oxidant.
Yep.
And you might think, that doesn't sound good. So let's take, say, vitamin E. Takes the electron, becomes a pro-oxidant itself because it's got this extra electron. It goes, shit. And normally that shuttles it around to another antioxidant.
Yeah.
But what if you just take vitamin E on its own, huge amounts?
Yeah.
It becomes a pro-oxidant.
You're making a pro-oxidant.
You're making a
pro-oxidant.
circulating
that. And so what is it that works with vitamin E? It's the A, C, and E together?
Well, not just together. You need more than that, because you remember how many antioxidants are there in food? There's thousands. In vitamin A, C, and E, there's 3.
Yeah.
Vitamin A, C, and E. So you need thousands of these things to actually shuttle these electrons around until it reaches what they call a terminal antioxidant, which takes it in and forms harmless substances.
Yeah.
And melatonin is a classic one. which is a chemical found in your brain and in your gut.
See, the tricky bit for us out there, the consumer out there is, what they used to do is they'd go through and look for vitamin A levels in food. But they had to have a marker for that. They'd test for one thing and then they'd talk about vitamin A yield proportional to this. The thing they selected for that was beta-carotene. Of
course, why not?
So then what they start doing, like for an example, they'd say, right, this product contains carrot extract, standardised to this much beta-carotene.
Yes.
And then you'd know, as a source of all the carotenoids and all the bits of vitamin A, how strong it is compared to the other foods. The problem is, we get trained to look for the word beta-carotene.
Yeah.
And then what happens is then people go, I'm going to judge my strength of vitamin A by the number of beta-carotene. So all of a sudden they ditch the carrot and then the brackets and all that sort of stuff and just leave beta-carotene as a big number so they can compare it to another product.
Sure.
And then the person will think they got better value taking the beta-carotene form. So what we've got to understand is when you take it out of whack and out of balance, you can basically take on all of this oxidative stress and become a source of oxidative stress in the body itself.
Absolutely, that's what it does. If you take singular
So then when you
antioxidants.
expose that to further oxidative stress, it can create damage to the DNA, damage to cells, and create things like cancers, heart disease. So for example, in that study with smokers, so they did a study with smokers and they gave them beta-carotene and found that those that took the beta-carotene actually got lung cancer more. They did the similar thing with prostate cancer.
Very much so.
And they found that when these people had oxidative stress, such as smoking, and you combined it with a
single
pro-oxidant or a single antioxidant that became a pro-oxidant because it was used out of balance, that combined with the smoking creates lung cancer.
Makes worse. Because you've got to remember vitamin A sticks around the lungs and beta-carotene.
It's fat soluble too, isn't it?
Fat soluble.
It sticks in your body altogether. Like it's you can't eliminate it as easily.
And lycopene sticks to your prostate.
Yeah. It's like a little... the prostate and the breast are the lycopene reservoirs of the body.
And so these singular things sound great in theory. Hang on, we've found a really cheap, stable antioxidant. Let's just give that. And it sounds good.
This is slightly off topic, but I've got to say it now because if this is running through your head like it is through mine while we talk about this podcast, you're probably going to get a little bit angry. And I've got a little bit of angst with me today because of this thing that I read yesterday. But there was a newsletter, it was like an interview thing come out. So there's a survey's been done and it stated that 83% of the population would not buy a synthetic multivitamin if it was labelled as a synthetic multivitamin, okay? So 83% said if we knew they were synthetics, we wouldn't buy them. 8% of the population surveyed said if it was labelled synthetic, they would buy it, for different reasons. If it was cheap, if their doctor said so. Only 4% of that 8% said that they would buy it because they believe synthetics are better.
Amazing,
isn't it? So 4% of 8%, don't make me do maths like that, man. But anyway, look, I'm seeing you crunching numbers now.
Less than 0.5%. Actually, it's 0.5%.
So bugger all people will take it. Now, that's all cool. Like, that's common sense. Why the hell would you take a synthetic chemical pooped out by a genetically modified bug, fed genetically modified sugars and crap? You wouldn't do that, man.
I wouldn't.
But you know why you would?
Why?
Because the wanker they interviewed from the big pharma company, you know what he said? He went and said publicly that this is exactly why we should not label our multivitamin synthetic, because the population is too dumb to know they will be doing themselves a disservice by not buying the cheap products that they can make. They said, why wouldn't you? The pharma company honestly believes that we're all too stupid and too poor and too broke to be able to use the gourmet shit, that they have to make a decision for us. They have to lie to us and fill ourselves up with synthetics because we're too stupid to know that synthetics are great. That's what he said.
Yeah, I know.
Basically, it's come out in the thing and said that if we labelled it as synthetics and people didn't buy it, they would be doing themselves a disservice. So they should be allowed to continually lie, which is going to get worse and worse because, with these dietary folate equivalent labels, all these new labelling laws are coming, it's going to be messed up. You need to work really hard at this. But to think that there's arrogant wankers out there that think that they're so much smarter than us and we're all so dumb and poor that they have to make decisions on our behalf and hide the information so we're not capable of making educated decisions. Oh, man, it makes me angry. Then you read papers like this. Now, that beta-carotene smoking thing, that was before 2000.
It was 94.
Yeah, there you go. So I know. So we're at 2018 now.
We are.
So we're over 20 years ago. They've known this for over 20 years. They still put beta-carotene in our supplementation, and they think we're idiots.
Yeah.
And they hide our information, try to trick us into thinking they're not giving us a simple synthetic beta-carotene. Oh, that makes me cranky. So that's probably my rant, but man, I'm going to carry on with some angst for a while.
Well, firstly, these synthetic vitamins, let's recap. They shorten your life slightly.
Yeah.
Okay. They are unnatural.
Yeah.
And a lot of people think 99% of multivitamins are synthetic. I can think of one that's not. What's its name again?
I wasn't even listening. I was thinking about that wanker from the big pharma thing.
So ours, of course, is non-synthetic. But the thing is that these synthetic vitamins are really easy to market. They're cheap to make.
Well, that's what this dickhead said.
Stable as hell.
They're stable. Yeah. They've got enhanced bioavailability.
Well, they have.
Well, they do, because the bastards can't be converted.
No.
So how do you assess bioavailability? Area under the curve?
Yeah.
So what that basically means is, as we absorb these vitamins, how long do they sit in our bloodstream for? Is talking about its bioavailability, isn't it? Like how fast it gets absorbed and what's the good blood levels of it as it transports around. Yeah. Folic acid, for example, good example. I know we're off topic. I'll bring it back in once. You're right. But the folic acid, for example, can't be converted.
Yeah.
So folic acid stays in your blood and causes lots of problems.
Big problems.
But they make out that that's the better one because of that reason. Because they're still stuck on that bioavailability model where you've eaten it, it's now in your bloodstream, it's all over your body, therefore it's therapeutic.
And I would argue that's not off topic, because antioxidants are found with B vitamins, these synthetic B vitamins.
Yeah.
So, if you get a multivitamin from a pharmacy, you'll see it's got how much of each vitamin. 99% of them have folic acid.
Actually, you're right, because what happens then is if we're stacking synthetic vitamins on synthetic vitamins on synthetic vitamins, for example, if you use too much B3, you need to methylate that for it to work. That uses up the methylation capacity for the folates. Therefore, you don't have the ability to methylate xenoestrogens, hormones, other toxic products and that sort of stuff that contribute to your oxidative stress. And then if you don't have the right ratios between your vitamin, we only got to A, didn't we? If you don't have your right ratios between vitamin A, C and E to be able to recycle these pathways, then you're overwhelming your system. So you're overwhelming your excretion pathways for starters, because your vitamins go through exactly the same excretion pathways as your toxins.
Yes.
So if your body's overloaded and it's too busy pumping them, something's got to wait.
Of course.
The conversion pathways are exactly the same conversion pathways for vitamins are our detoxification pathways for toxins.
Yeah.
So if they can't convert a vitamin into its active form, they can't actually convert a toxin into its inactive form.
Yes.
They get the same sort of process.
Yeah.
And then the end result is DNA damage and all that sort of stuff.
Absolutely.
Contributes to cancer and further oxidative stress.
Absolutely. It gets a little bit worse than that too.
Oh, awesome.
But yeah, awesome. Let's say, I would assume most people listening exercise.
Yeah.
Don't they?
Yeah. Look at them.
You have to. Now let's say you have antioxidants during the day, so your multivitamin, synthetic antioxidants, you pump them down like you do.
Any antioxidant. Good antioxidants too, wouldn't it?
Well, yeah.
Because we eat a lot of antioxidants.
Yeah. And that actually inhibits the adaptation to your muscles that adapt when you exercise. So you need a level of free radical action.
So you need damage.
You need a bit of damage.
Yeah.
And it's like the going to the gym, you damage your muscles slightly and they grow back bigger.
Yep.
You need that free radical damage to get, signal into the muscles. And that was published in 1986. I've got a graph here that I've probably
inflammation, oxidative stress.
Yep.
Even nitric oxide vasodilation, I'll talk about oxygen about that in a sec too. But
sure,
those things, they all contribute to what's the word? Mimicking an injury.
Yes.
And then your body's forced to recover with more. So you're saying preloading with antioxidants will stop that from happening, or reduce your hypertrophy?
It reduces muscle adaptation, and this is a paper study published in the Journal of Physiology 2016.
Yeah.
So it basically showed that you need some free radical damage to induce muscle adaptation to improve your health and improve your performance.
Yeah, cool.
I don't know. This is a nice graph. We'll see if we can get a close up live. But we'll see what happens there. Yeah, we've got that.
That's right.
So there you go. So for people watching, you can see the graph. For those who aren't, stuff you.
There's other arachidonic acid in. I've seen a similar paper with COX-2 inhibitors, anti-inflammatories that have reduced the inflammation and then reduced the hypertrophy. And I've also seen other studies with such things as arachidonic acid supplementation that induces further inflammation. to create more injury, and then for people that hit a plateau, can help them to kind of start feeling sore again and then start recovering.
Yes.
With some of our athletes, we will use sometimes our multivitamin, our multi-food, which is all food-based antioxidants and vitamins, mixed in with something like AMP-V, which is a fat-soluble, it's mainly essential oils, which have got some antioxidant properties, and it also got a lot of essential fatty acids.
Yeah.
Now, when I give that multi-food AMP-V combination to my athletes, they perform really, really well. Like they hit PBs, their brain is sharp, their energy levels are excellent, they perform really well. But are you saying that if we do that strategy, if your goal is not necessarily performance, so if your goal is not necessarily being the strongest or the fastest or whatever, but if your goal is to be big, so bodybuilders shouldn't do that?
Well, this was done on huge levels of synthetic vitamins.
Oh, okay.
So natural foods, I don't think would have the same thing because the body is used to having natural foods.
Yeah, but they're more effective, aren't they? Like, you think the natural foods would be...
They are more effective at being natural antioxidants. But
so if you want to build muscle, Steve, like if your goal is hypertrophy, you want to get massive, and you don't really care whether you've got massive muscles and you're curling 5 kilos or 50 kilos, or you're not going to compete, you're not a power lifter, you're not an athlete in the sense that you're not track and field and that sort of stuff. You're a bodybuilder that's trying to create hypertrophy. You wouldn't use antioxidants pre-workout, would you?
No. And the reason being is because you want to induce some muscle damage.
Yeah.
So, you could train, for example, what I do is pre-breakfast training.
Yeah.
Sure, I have some AMP-V.
And you're huge.
And I'm huge.
Yeah.
This ridiculous muscle there.
But yeah.
No, it's a normal time to train. I mean, you got to remember that we wake up in our cave 100,000 years ago.
Yeah.
We don't just have a snack from the fridge before we go and quote train or climb a tree or chase an animal down, eat it, or hunt and gather.
Yeah.
We had to do it fasting.
And if you go into that, so if you do that before breakfast and that sort of stuff, and you start going into fat burning, I mean, what's fat burning called? Fatty acid oxidation.
Oxidation.
Hey, do antioxidants stop you from burning fat?
Yeah, that's my next slide here. It does. There was a study done in this one on the harms and benefits in human health.
Yeah.
And one of the things is antioxidants can
reduce fatty acid oxidation
in the mitochondria.
Yeah, wow, man.
Yeah. So this is just common physiology.
And you know what's cool about that AMP-V with peppermint oil?
Yeah.
It increases fatty acid oxidation by increasing the oxidation aspect of it.
It's not.
That's wild,
It's
man.
not a bad thing.
Yeah.
Now let's contrast that with natural antioxidants.
So hang on, I haven't finished yet.
Oh, okay.
So bodybuilders,
to
get massive, don't preload with antioxidants.
Correct.
You want to be sore.
You want to do damage.
So we also have another product called infrared, which is made for, again, performance. It's a performance fuel. It's got schisandra in it, brilliant antioxidant. It's got other acidity buffers and bits and pieces, but that's designed for performance.
Yeah.
So in those sort of things, so the point is I'm trying to make is what we seem to find is to have performance, to have endurance, to have the ultimate your fastest times and PB lifting, it's okay to have the antioxidants because you get better endurance. You perform better with antioxidants.
Yes.
But if you want to exaggerate the injury to the muscles, you
which
don't
is
want to be protecting it with antioxidants.
So it's like
if you want to burn more fat, so if you want to be breaking your body, so if you want to break down your body to induce hypertrophy or break down your body as a fat burning strategy, you wouldn't want to protect those tissues with antioxidants.
No, and you don't want to take carbohydrates either, but carbohydrates will improve your performance.
Yeah.
So there's a time and a place for these sort of natural antioxidants. And when you're training, you want to make it as hard as possible. That's why you lift as much as you can at the gym. You don't go there to walk on a treadmill.
And then focus on your nutrition to support hypertrophy and recovery.
Correct.
So you cause exaggerated damage to get exaggerated response in healing.
Exactly.
But you need to fuel that exaggerated response in healing to be able to get the gains. Otherwise, you break yourself down. And if you're not actually rebuilding what you broke and adding a bit more, then you're actually going to go catabolic.
Correct.
So for those people that talk about overtraining syndrome, they're actually breaking down their tissue. They're not recovering fast enough. So their issue is not excessive breakdown. It's usually lack of recovery.
You know, like I'm a fan of the No Way. I have No Way every day, and that's simply because like this morning I did a 12K run, and I know it's not a super long run, but I'm a pretty friggin' old bastard. I'm 49.
Mate, if that bastard was still chasing you after 12 kilometres, I don't know what the hell you did. You might have had his breakfast.
It's funny, I was talking to one of the staff here.
I only ever done a 12K run once when my dog followed some jogger down the beach and he wouldn't stop. And I'm running after him going, man, I'm yelling at this guy. I was losing. Because if I had the stamina to do one last sprint, I would have taken him out just to get my dog back. Well, I'm yelling, like, stop, man. He's got his headphones in. He's running the whole bloody guy. He almost ran Southport Spit.
Good exercise.
If I guaranteed he was coming, I didn't know if he was on his way up or back.
Well,
otherwise, I would have waited for him to come back with my dog.
The spit ends at that seaway, so it'll.
I don't know if he started there though, and he was on his way home because he was pumping out. Surely he was on his first leg. Anyway.
Oh yeah, look, it's crazy.
What the hell are we talking about?
Oh, look, pro-oxidants and stuff. But yeah, that's right. You've got to do the damage to get the benefit.
Recovery. So, vitamin A.
Yeah.
So it works as an antioxidant, fat-soluble antioxidant. Yep. Vitamin A typically famous for living in mucosa, our epithelial lining. So vitamin A as an antioxidant is really important for skin.
Yes.
It stops sun damage. In fact, a lot of the carotenoids will actually give you a tan.
Yeah.
They look like a tan, depends which. If you can get the right mix, man, you might get a bronze. But most of them are orange and yellow. You come out looking more like Donald Trump or The Simpsons.
I did a bit of a Simpsons thing when I went to a conference where they had beetroot juice and carrot juice as a free drink.
Yeah.
And I was just drinking.
Oh, you give free stuff to Steve-O. He'll smash that.
I was orange. I was feeding him orange.
Yeah, and for the listeners out there that go bright yellow and then they're curious, am I... Keratinosis, jaundice or Simpsons.
Yeah.
How do they tell? So whites of the eyes. So when you get the keratinosis, your whites of the eyes don't go orange.
Yeah,
but if you've got jaundice, your eyes go yellow. And there's also the palms of the hands.
Yeah.
Yeah.
Palms of the hands are very orange too.
Yeah.
It should be slightly orange because you've got to... Have you ever seen those machines where you put your finger on and they measure the carotene level of your skin? Oh, there's a machine where you put it's a light that passes into your finger and how much of the refraction of the carotenoid wavelength. Yeah, it's an antioxidant measure machine.
Yeah, cool.
And you put on it. I was in an American conference a few years ago and mine was really high because they had a lot of vegetables. In America, they don't.
Yeah.
Except potatoes.
And most of them are low.
Very low. They said,
because the carotenoid's got colour.
Yeah.
So that's why they're either the crazy dark greens and blacks and stuff like that, or at least orange.
And the plants make them to protect themselves from the sun.
Exactly.
I mean, there's a tree out there now.
Protect what aspect of the sun?
Oh, the UV damage.
Yeah, the oxidative stress.
Yeah.
Yeah, so their antioxidants protect the tissues.
Yeah.
I'll tell you something cool, just while we're talking about that. The botanical antioxidants, a lot of the botanical antioxidants are also found in the peels and the outside, of course, to protect from that oxidative stress. But also, a lot of them are poisonous to microbes. And so what happens is they stop the polyphenols we talk about. The microbes can't get into the sugar because they're poison in the skin. Then when we eat them, our body picks up on a little bit of this poison. And I'm talking about things like schisandras, resveratrols, a lot of the other polyphenol modbiotic compounds that we find in the fruits and the peels. They actually trick the body into thinking you've got a big dose of poison coming. And so then the liver responds by creating antioxidant defense mechanisms.
Yes.
So some of the mechanisms are NRF2 activation and then also just straight out exposure to certain poisons that are known poisons by the body that it has to create a protective effect against it.
Yeah, because your body makes antioxidants.
And so when these herbs get the stimulation to induce a protective effect, they then ask the body to grab nutrients and make antioxidant molecules like glutathione.
Yes.
So the point is, some people think, if I take enough antioxidant herbs, I'm going to have this antioxidant defense.
Yeah,
you need the nutritional profile. If you've got deficiencies in vitamins A, C, and E, and other vitamins and amino acids, the herbs are going in, they're asking the body to do something, but they may not be capable of doing it.
Correct.
Or if you've got the wrong balance. Do you want to tell us about how vitamins A, C, and E really work together?
Sure. They shuttle around free radicals. So for example, if vitamin E, say you get a free radical damage to your skin, you get sunburn. Okay, most people get sunburn. The vitamin E cops that. And so the vitamin C is not fat soluble. So then the vitamin E gets in the blood and the vitamin C takes that free radical and forms a soluble free radical.
Yep.
And then, of course, it shuttles it around to all the other natural antioxidants. Your body makes glutathione, superoxide dismutase, which if it's a superoxide free radical, O2 radical naught there, then that gets rid of that.
Yeah, right.
But Because that's a terminal antioxidant. That's
so what's this recycling? You know, when they talk about the ratios between C and E being so important.
Yeah.
How does that work again?
Because if E gets a free radical, then C can help it out.
Yeah, right.
And if C gets a free radical, E can help it out. So they do help each other, and eventually they shuttle these electrons around. They can store them for a short amount of time.
Between fat soluble and water, between the fat compartments and the water compartments.
Correct. There's not many antioxidants that do both. Thiatic acid or lipoic acid is one, but there's usually in certain areas of the body where the antioxidants hang out.
Yeah, right.
So that's the ratio between them, and then your body makes the most common sort of antioxidant deficiency is zinc deficiency.
Yep.
And you don't make the zinc superoxide dismutase. Yeah,
that's right.
And if you can't get rid of superoxide, then superoxide reacts to the nitric oxide inside your blood vessels, and you get the peroxynitrite free radical, which is the most DNA damaging thing, and that can cause cancers and those sorts of things.
So, while we're talking about peroxynitrite free radical then, so, vitamin C, when you talked about it as an antioxidant, do you want to quickly tell us again how vitamin C enhances the absorption of iron?
Oh, yeah.
Through that same sort of mechanism.
It does.
And and then explain what happens when you throw vitamin C onto other heavy metals and that with high doses. Yeah, it's a bit of a problem. So iron is in if you look at the periodic table, which is that castle-looking thing with all the little 92 elements on it, and iron is about, I think it's 26 in the periodic table. 26 in the periodic table, and therefore it's what they call a transition metal. In other words, it's a metal that can be a couple of different valencies or charges. It can be Fe2 plus or Fe3 plus. Fe2 plus is a synthetic one that they give to the doctors prescribe this iron in the form of fefol, if you've heard of that. It's quite a toxic form, 2 plus. Now, what vitamin C does is vitamin C accepts electrons from, free radicals, but it can also accept electron from iron. So it turns Fe2 plus into Fe3 plus, and that enhances its absorption, because Fe3 plus is what the body makes hemoglobin out of. Yep.
Sorry to get a bit too chemical.
No, it's good. So basically, vitamin C, through that antioxidant mecanism, will actually change iron to make it to an absorbable form.
Correct.
And while we're talking about iron, and for people with endometriosis or hemochromatosis, this is really important.
It is.
If you get too much iron in your body, and vitamin C is that effective that it can actually enhance your iron absorption to a point where you get too much iron.
Correct.
And then what happens to the too much iron that doesn't make it into hemoglobin or gets liberated from hemoglobin in the case of endometriosis and hemochromatosis? It oxidizes.
Yes.
And what happens when we oxidize iron? We make rust.
Yeah.
Iron oxide.
Yep.
There's a lot of the pain associated with endometriosis is associated with the destruction of the red blood cells in the peritoneal cavity, basically not in the reproductive tubes that can be just fall out. That's probably a bad example, but you know what I mean? Like if it's in the bowel and if it's in the reproductive tract, it can be passed and eliminated. If it's released in the peritoneal cavity, this iron and all that scar tissue and that blood gets broken down, that iron is left liberated floating around.
It's iron 2 plus. It goes back to the 2 plus form, and that's rust.
Yeah.
Iron oxide or iron sulfate is rust.
Yep.
And that usually, like hemochromatosis patients, the major side effect is the liver.
And that rusts.
And rusts the liver, causes free radical damage.
And endometriosis, it's happening floating around between the layers, which is why it bloody hurts to move, because the layers all get glued together because of all this oxidative stress and inflammation. So
awful disease.
Antioxidants is so important in those cases to protect from that iron. Now, what if I take mega doses of vitamin C just for shits and giggles, and I just happen, like everyone, to have heavy metals and bits and pieces floating through my body?
You're in trouble, because it can enhance the absorption of iron, and that can be highly problematic for people with hemochromatosis. Just for those who don't know, hemochromatosis is a condition where you can't regulate your iron absorption. Most minerals, if you have a lot in your body doesn't absorb them. Hemochromatosis, they just absorb iron, whether they've loaded up with it or whatever, and that's a problem. We talked about that with magnesium a lot. With low dose magnesium is better than one super high dose, and that's why it regulates it. So if you have a lot of minerals in your body that are what they call the transition minerals, the ones that can change valencies, like chromium is a classic one. There's really dangerous forms of chromium, the hexavalent form. Have you ever seen that movie with what's her name in it, who talks about...
Oh, what's her name movie?
Yeah, the what's her name movie talking about all the chromium poisoning?
No.
Oh, okay, the lady who...
Oh, Aaron Brockovich thing.
Yeah.
Oh, yeah.
So that's.
I had to think, how old is he? Is he talking about Marvel, X-Men? Like, what the hell's happened? Oh, Aaron Brockovich. I was talking
about Charlie Chaplin, my age, mate. But that was against chromium. But the hexavalent, the plus form. But if you take the 3 plus form, it's really good for your
blood sugar and everything.
All sorts of shit.
But otherwise, when you put too much vitamin C onto your heavy metals, you make peroxynitrites, hydrogen peroxide, and that's how you can turn vitamin C into a pro-oxidant. And that's why they do IV vitamin C, to create pro-oxidative things to kill off cancers and viruses and that by generating hydrogen peroxide and peroxynitrites through your body to sterilize anything it touches.
Well, absolutely. And when you've got a virus, antioxidants can be useful in certain amounts. There's a study
antioxidants for viruses.
Yeah, or the effects of a virus. If you want to read that one out, that's a study showing antioxidants protecting against the myocarditis, which is the inflammation of the heart. From a virus. What virus?
You can do that virus this time. I'm starting to get a bit of oh gosh, I got to get cocksucky, Steve. It's cocksucky. You little dirty man. I can't believe you tricked me into doing that again. The old chin nut virus.
Chin nut virus, yeah. Oh, red pen, look.
No, you don't need a red pen for that. Geez. It's a virus. Coxsackie bee. Just spell it out and we're all good. COX. Yes, buddy, whatever.
Virus. Yeah. So antioxidants, but it depends on the form. And I showed you a paper before about the oligoproanthocyanidins, which are natural antioxidants found in foods. Yeah. They can act as pro-oxidants, but only in cancer cells.
So what?
Right. So antioxidants, protect against oxidation, but if they're the right kind, the smart kind, the plant kind, the healthy kind, you can eat them and your body can make free radicals out of them to help kill cancer cells.
Ah, wow.
So that was, there was a recent study on that.
But my understanding while we're talking about cancer is we've got a cell progression. So the cells typically progress.
Yes.
Things that we call carcinogens, so cancer-causing agents, like the burn, all the nice stuff.
Insulin.
Anything that's great is typically a carcinogen.
Insulin, sugar.
And carcinogens speed up the cell cycle and make the cells progress at a faster rate. Now, our cells have these little checkpoints. If the cell's not quite right, it's supposed to say, man, you're an idiot, you're doing it all wrong, go and self-destruct. And it's called apoptosis, but they induces a self-destruct mechanism and says you're a useless cell, you've done it all wrong, just go. And that's what happens. Now, antioxidants are famous in cancer prevention because they slow down the cell cycle.
They do.
And offset the effects of carcinogens, speeding it up. And by slowing down the cell cycle, the little checkpoints can start to work again. Yeah. A lot of antioxidants help those apoptosis mechanisms by saying, hey, this cell's defective, induce that gene to go. A lot of carcinogens and oxidative stress wreck the gene that induces apoptosis, so they've lost that mechanism. Yeah. Furthermore, antioxidants will stop a blood supply to a cancer, a process known as angiogenesis. Correct. So it'll inhibit the blood supply to a cancer, slow down the cell cycle, induce apoptosis, all that sort of stuff. The other thing I know they do is they protect cancer cells.
They do.
Antioxidants will protect a cancer cell from radiation. How does radiation work? Oxidative stress?
Ionizing radiation. Yeah.
So oxidative stress, radiation. So you give someone an antioxidant when they've got cancer, will it protect them? But you're saying that nature's really awesome in the ability that it has these antioxidant aspects in regards to cell cycles and prevention. So this is why things like turmeric as well are suitable for every stage of cancer development, progression, all the way through to metastases, because it will actually change the way it works.
It does, because remember there's regulatory proteins called Ps, and the most famous one, if you want to Google this one, is P53.
Yeah.
P53 regulates those checkpoints at the S1 phase where you get the growth of two new when the cell splits off, so it regulates that. Epigallocatechin-gallate or green tea regulates that as well, so that's where there's a benefit there. But P53 protein is upregulated by these powerful antioxidants and downregulated by smoking. And that's why people who smoke get cancers everywhere.
Yeah,
they get
right.
More, not just lung cancer, but they get more breast cancer.
So that mechanism that says you're not supposed to be dividing is blocked by these carcinogenic things. Carcinogenic
and the cyclins are the things that speed up the cell cycle you referred to. One of them is insulin. So if you're going to eat a high carbohydrate diet, you're going to be much more prone to getting cancers. That's
a lot of other anything anabolic is, isn't it?
Yeah, of course.
Most of the anabolics are stimulating cell cycle, cell progression.
Like mTOR.
Antioxidants can slow that down and protect you a little bit. But yeah, it's really careful. If anyone's out there, with cancer, the biggest thing that everyone used to do in the clinic is lie to their oncologist and tell the truth to me and put me in a really awkward position. So you've got to be truthful with your doctor. That's when cancer to say, I'm considering using some natural stuff in conjunction with chemo, radiation. And then we can communicate then, and we can share information and show some things that do work well or been studied with the medication to show they work.
Yes.
Do not lie and be very secretive and actually throw in stuff on the side that might actually protect your cancer cells from the poison.
Exactly.
You need a strategy. If you're going through the poison, man, you want your cancer cells to get all of it. Yeah. So
I'll read you this
as a disclaimer. There you go.
Yeah, be careful. Now, you've heard about plants having loads of antioxidants. I'm going to contradict myself and say plants are pro-oxidants in certain circles. I'll read this out to you.
Bring it on, Steve.
Pro-oxidant polyphenols, this is the pro-oxidant section, seem to exert their cytotoxic activity by inducing apoptosis, cell death, and cell cycle arrest via several pathways. Anthocyanidins, pigments present in red wine and berries, etc., can cause apoptosis or death in cancer cells by increasing intracellular free radical formation.
Yeah.
So that, I know that, sorry about the language, but that shows you that they are pro-oxidants in cancer cells. So that's why the plant antioxidants are so beneficial for you, because they protect against getting the cancer. And when you get it, it's like turmeric.
And exactly. Yeah. And then you briefly mentioned rosemary, and I interrupted you. And rosemary is famous for blocking those G protein pumps that pump those toxins out. And that's one of the ways that cancer become resistant to both pharmaceutical and natural treatment is by having these pumps that go, pump all this pro-oxidant stuff out, it's killing me. Yeah. So rosemary works with reishi mushroom, and they block those G protein pumps. That allows the antioxidants and things in turmeric and what was that one? What did you say before? Yeah. Those, say it again for everyone.
Proanthocyanidins.
Yeah. See, I just
the coloured stuff in fruits and vegetables.
Yeah, and I just go, that grape seed stuff.
Antho is many, and cyanin is a colour of red.
Yeah, right.
So have you ever seen the?
Is cyanide red?
No, it's odorless. But cyan.
Odorless.
Cyan is a colour.
What does red smell like?
Odorless. I don't know what red smells like. It smells like red.
I just said it's cyanide red, and you said no, it's odorless.
Oh, okay.
And I was like, whoa, what does red smell like?
It's colourless.
Rose.
Because cyanide's just C(-), which is it's carbon and nitrogen joined together.
Yeah, right.
In an ionic form, which
amazing
is bad.
Sort of shit that'll kill you. Like seriously, 80% of our air is nitrogen. I'm making up stats now.
It is.
So there you go. There's one of my 80% of stats that are made up on the spot that were correct. 80% of the air is nitrogen, and the rest and everything's bloody carbon.
Of course, but when you join it in this ionic form, it forms C(-), which simply disrupts your electron transfer chain, so you lose energy and you die. That's how it works. Can I take you back to the Nuremberg Trials in 1946? A lot of the Nazis killed themselves by chewing on cyanide tablets because instant death. Yeah, there's no cure.
They feel really bad about killing all.
They just want to be sentenced to, forever in jail, I guess. So they, and I think Goring was one of. I can't remember the names of the people who cyanided themselves to death. But there was a few of them. Good riddance. But you mentioned turmeric before. Turmeric, a compound extracted from curcuma longa, induced radical-mediated apoptosis in human gastric cancer cells. So it protects against getting it in the first place. But if you get it, it helps you treat it as well. So turmeric stops you getting cancer. Yeah. But if you've got it, you need to take it. Yeah. And it kills the cancer.
Yeah. Yeah.
So it doesn't kill cells normally. That's how clever this stuff is.
It's cool,
and it's almost like people sit there and go, so is it a... Because you've got to remember, medicine, if this is a drug, it does one thing. It inhibits or it enhances. Usually inhibits. As most drugs inhibit inflammation. COX-2 inhibitors, they inhibit COX-2. End of story, no debate. Sure, it's got side effects, but that's what it does. These things actually keep cells alive by protecting against cancer. But if you get cancer cells,
it kills them. State-dependent effect.
Yeah.
They got that ability to switch between. So that's the coolest thing about herbs. There's a lot of adaptogenic effects that they will have a different effect depending on what the body's priorities are.
Absolutely.
They're so clever, eh?
It's
freaky to think about, really.
My wife, Rebecca, is a nurse who works, sometimes 9, 10 at night, right?
Oh, yeah. I thought you were just going to finish it sometimes then, that's all.
Yeah, sometimes she works. But she'll take Cordorex and be very, very relaxed. Remember we got that text out for dinner and that. And I said, look, Beck's just, taking a Cordorex. But if I take Cordorex, I feel great in the head. And I took some about 2 hours ago, or an hour ago, and here I am at a podcast, my mind's sharp, and it's like... Bzz, bzz.
Yeah, but we got a lot of studies on those adaptogens showing even different effects on cortisol morning and night. They just fix in with your diurnal rhythm.
Absolutely. So you've got to remember that when people say antioxidants and you think ACE, and you take them, we know from a Cochrane Library database, systemic review of 78 studies, it's not going to do you any good. In fact, it probably does you
so
harm.
when you are getting vitamin A, look for vitamin A from foods, or just buy our product because we get vitamin A from foods. Otherwise, what you want to look for is things that have got beta-carotene, alpha-carotene, beta-cryptoxanthins, all those other foods. You want it standardized from a plant. So you just want it to be a plant, but not a plant with a token gesture spiked up with beta-carotene.
Yeah,
Very really careful it's not spiked. But there's like that wanker I said before, that Bodie's lying, that says, but don't worry, you're an idiot, so I'm going to lie to you. How the hell are we going to read a product and know if these idiots are lying to us and not wanting us to know they're synthetic? They will actually say beta-carotene sourced from this, or as an example from this, knowing that no one can really probably prove it wrong unless it's pure beta-carotene, you know? So look for those plants standardized to supply carotenoids. You got to mix it up with nature. I don't care what you're doing. If you're not covering the other carotenoids with all of your green leafies and lycopenes and other bits and pieces, then you're in trouble. Yeah. Now, vitamin A, vitamin C and vitamin E. Yep. So with vitamin C, the doses that you need to incorporate for it to work in its jobs through that same electron mechanisms, it creates tyrosine and amino acids like carnitines and that sort of stuff. It hydroxylates proline to make cartilage. All of the jobs of vitamin C regarding around fatigue and collagen. So that whole vitamin C. When you've got none, the first signs of scurvy is just fatigue because you can't regenerate your catecholamines. Yeah. The second one is you can't regenerate your collagen, so then your gums start bleeding and all that sort of stuff. It's very easy to fix that again just by topping up a bit of vitamin C and all that sort of stuff fixes.
In the 17th century, they figured it out.
Yeah.
Back when Captain Cook was sailing around 1770, he was famous for being a progressive captain. He wasn't actually a captain; he was a lieutenant. He didn't even reach captain, by the way.
Yeah, really?
He wasn't even
Is that right?
Yeah. He was a lieutenant in the Royal Navy. He wasn't a captain.
And he ballsed up the whole tracking of the moon, didn't he? And accidentally found Australia.
Well, no, he didn't ball.
He was only here to do some astrology thing, isn't it?
Astronomy.
No, it's astrology. Someone said, today you're going to find a landmass. And they said, which animal are you? And he said, I'm the water dragon. They said, that's not one. None of them are.
None of them are real, it's quite funny because he gave his he stopped at some of the islands and he gave all his crew lime juice. Yeah. And it protected them against scurvy. Yeah. And vitamin C was thought to be, this, or they didn't know what vitamin C was.
So the levels though, so when we're looking at supplementation, like, I remember naturopath college, they said, mate, give it till they got the squirts. Yes. And then when they got the squirts, their levels are topped up. Why have they got the squirts? Because it's water soluble. Rubbish. Yeah. It's because it's making peroxynitrite and hydrogen peroxide in the bowels and sterilising everything. The doses for vitamin C, you don't really need much more over a gram a day. If you build up to a gram, 150 milligrams is enough to saturate your immune cells to follow through on that famous vitamin C claim of it'll improve reduce the duration of your cold and flu by 2 hours over 3 days, which is, that's something to be famous for. Vitamin C IV is not for glutathione production. It's for a pro-oxidant to sterilise. The dose of vitamin C quite small. Vitamin E, what people need to realise of vitamin E, again being fat soluble, they talk about, and in those Cochrane Review studies, they're talking about mega dosing vitamin E causing heart disease and not protecting them from cancers, causing these things. When looked at those doses, they're 400 IUs. Mega dosing of vitamin E is not like, I didn't think that. Like a lot of capsules start at 500. Yeah. Like most of the products on the market are 500 IUs. Most people are out there are aiming for 1,000 IUs per day. Anything over 1,000 IUs suppresses your immune system, slows down healing, which is why you don't get scarring. But the cool thing about vitamin E is very low dose consistently is adequate, and you need your vitamin C and your vitamin E to both be relatively low and in balance and constant supply.
Constant supply. And the thing about vitamin E is it's usually alpha tocopherol.
Oh, yeah, now, man.
Alpha means something, doesn't it? And there's beta and gamma, and there's other tocopherols.
Alpha, beta, gamma, delta. There's like,
and then there's the tocotrienols, which are the other four. So most vitamin supplements, and for those at home, check your vitamin supplement, see if it's got alpha tocopherol or mixed tocopherol. Do you want? If you're going to take vitamin E, take the mixed tocopherol.
Same thing with vitamin E. It used to be always wheat germ oil, standardized to D-alpha tocopherol because that was just the first one and the marker.
Yes.
And why not just all use the same marker? So we're comparing wheat germ with wheat germ. And then what they did is they realised everyone was looking for how much D-alpha tocopherol. Quickly drop out the wheat germ.
Yep.
Let's put in some D-alpha tocopherol. We'll put that within a beta-carotene. They'll already be taking a couple of grams of vitamin C because the vitamin shop lady has been trained to pump out 5 to 6 grams a day until they get the squirts.
Yep.
So this is the big problem. And then you've got the wankers that make the pharma synthetic crap lying to us the whole time and refusing to give us the proper information. But because we're poor and dumb, just look for the cheap and nasty crap because that's the fair chance they're doing just for us.
Yes. And you got to remember, most animals make their own vitamin C, like cats and dogs, and most animals except for guinea pigs. That's why you ever heard of using guinea pigs in trials, because they can't make their own vitamin C.
Yeah, right.
No, neither can monkeys and bobos, which are our closest, genetic relatives at 98.7.
They make it from glucose, don't they?
Yeah.
Yeah.
It's simple.
Wouldn't that be cool, man? If we could eat carbs and turn it into vitamin C. No, we're forced to eat these damn fruit and vegetables.
We turn it into fat on our ass.
Yeah.
Well, because, animals like a cat can, scavenge and just eat meat all day and survive, birds.
And so because dogs, for example, have developed this ability to make vitamin C from glucose, they therefore do not need to eat citrus fruits.
Yeah.
So what happens when a dog eats a citrate?
Yes. Very problematic, isn't it?
Exactly, which is why when the people write the memes about citrates being bad, they're talking about bloody dogs and rats that can't eat those foods, not humans that have evolved an ability to eat those foods because we didn't evolve an ability to make vitamin C out of glucose.
Well, we lost the ability about 30 or 300,000 years ago to make vitamin C. Before that, we could.
Oh, really?
Yeah, apparently the Australopithecus was the last of the species, the hominoid species that could make vitamin C.
Oh, man.
And the hominid precursor. So we have lost that ability. So we all had it, and then we lost it because we got loads of vegetables and fruits and all that sort of thing. We do that sort of stuff. So, it's we're the ones that are deficient of it. Most animals just make it, like rats and everyone makes it.
And that's why you really need to pick the right animal for the right study or the right assumption when you're attacking something.
And as I said, if you ever heard the term, guinea pig is I'll be the human guinea pig. Well, that's where the term comes from, because they were the first animals used because they don't, make their own vitamin C.
Yeah, wow.
So I don't know if that's interesting for people.
I find that shit interesting.
Fascinating stuff, yeah. but like the old scurvy and all that sort of stuff. The vitamin A story, the funny one is that has been one vitamin. That's vitamin that's killed someone.
Yep.
That was the Scott in his Antarctic and his crew who ate the polar bear liver. And
he went blind. And so it fixed their night blindness really good, and then they couldn't see anything. Yeah,
and then they just got blind and died. And, they could have died of anything out there. They were pretty ill prepared.
So basically when we're looking at these things, so we got vitamins. So when you look at eating fruit and vegetables, we're going to get all the vitamins and minerals. So we're going to get the nutritive antioxidants out of it. We're also going to get the polyphenol and all those sort of compounds out of the skin. But on top of that, we're going to get a big mix of the stuff we don't really know about yet, because nature's smarter than all of us, including that farmer guy that said he's smarter than us. But nature's even smarter than him.
Way smarter.
We deserve the right to be able to kind of work with nature, because we kind of all arrived here together.
Yeah, absolutely.
So I reckon what we're looking at is a good mix of fruit and vegetables.
Yep.
You standardise some of your vitamins using a thing like multifood, where someone's actually gone through and worked out that you've got a certain dose of these vitamins, so you can make sure you're not deficient in things, because we don't really know, even if we eat organic and all that sort of stuff, we know there's not crap on the outside, but we don't know what's on the inside. Depends on how much rain and all sorts of bits and pieces.
Yeah, exactly.
So eat a big variety of diet, use the nutritives like we've standardised in the multifood, the herbal anti-inflammatory, the herbal antioxidants, the turmerics, the schisandras and all those sort of things, they can all come through because they seem to have a state-dependent effect, and if you use them in their close to natural state, you're better. Don't get a green tea that's just EGCG, because it's not green tea. Yeah. They've mixed a lot of the other cofactors, and just like we've discovered with beta-carotene, just like we've discovered with D-alpha tocopherol, we're starting to discover the same sort of things with EGCGs taken out of balance. When people take active ingredients out of a herb without the rest of the herb, they cause problems.
Very big. And you've got to remember that nature is very smart. I mean, I'll just bring up the cyanide tablet again. If you have a cyanide tablet, you die rapidly.
Yeah, that's
But
clever.
if you have cyanide in food, it's actually healthy for you.
Yeah, like apple. Is that in the apple seeds?
No.
That's
there's oligoproanthocyanidins has cyanide. So in nature, it's fine. So again, these antioxidants are very clever, and nature is extraordinarily clever.
But it's a balancing act. It's an exchange. You can't just overload one and think it's going to have an antioxidant effect, like load you up with antioxidants forever.
Yeah, exactly. And you've got to try and have plants that grow above the ground because they require more antioxidants to protect from the elements.
Now, I have been smashed with the reason why I want to do this oxygen podcast and antioxidants, because we've been getting heaps of weird ass questions about hyperbaric chambers, hypobaric chambers, oxygen drops, lixigen. I don't know what the fuck I was trying to say there. Liquid oxygen. Liquid oxygen. So and now they used to be hydrogen peroxides and other peroxy nitrites. So that people think they're doing this stuff. So we're going to run through all those. So let's start with hypobaric chambers.
Hypobaric chambers.
So that's less oxygen.
Pressure,
less oxygen.
When there's less oxygen around, your body adapts. Okay. Yep. So let's say you're up the top of the Himalayas. Yep. Okay. Which is low oxygen, because oxygen is a molecule that's heavier. It's heavy and it's attracted by gravity, so it falls to the low areas. So if you're really high, there's low oxygen. So it's like a hypobaric chamber.
So it's like training at altitude. You're getting less oxygen delivered to your tissue.
Correct.
Which forces you to change and adapt.
It makes more red blood cells to carry what little oxygen there is to make more things. And there's a drug called hemochromatosis, or that's the process.
Yep.
And hematopoietin is the drug.
Yep.
And unfortunately, a lot of the cyclists got busted for that sort of stuff. You know, the old Lance Armstrong E-type.
I'll tell you another interesting thing. Hypobaric. And so some people can train at altitudes. Some people can use other things to reduce... to enhance oxygen dumping or to and maximise how much oxygen they can carry around, which is building more red blood cells. Things like coenzyme Q10, Shilajit, dimethylglycine. Those are the sort of things that have been shown to enhance oxygenation of a tissue.
Correct.
Also, your body may adapt to a to a low oxygen environment by making their systems better at doing so.
Correct.
Making more mitochondria even, that sort of thing.
And if you want to cheat at sport, like Lance Armstrong, what he did was he gave blood and put it in a bag.
And then whacked it back in later.
So that you don't want to do that. I'm not slandering the guy because he pleaded guilty to it. So
eventually.
But so that's the hypo oxygen or hypobaric chambers. Then we've got the hyper.
Can I tell you one more cool fact about hypobaric? There was this wicked study they did not long ago where they found people that went to high altitudes. What do they call them? Concentration camps? No, high altitude. What do they call them? Health retreats.
Yes.
So they go health retreats in high altitudes, and the people that got great results in those maintain those results if the higher the altitude that the health retreat was at. And they think it might have been something to do with the adaptation from the lack of oxygen. There's also some interesting stats when we have low pressure systems. They get more police emergencies, more hospital stuff going on with a low pressure system than they do with the full moons. Because again, with a low pressure system, we have less barometric pressure and less oxygenation into our tissues.
Correct.
More likely to build up acids and that sort of stuff, which can cause our brain to go stupid.
Well, also
hyperbaric,
Hyperbaric is when you've got a lot of oxygen around. So when you want that, of course, is when you're trying to do recovery and that sort of thing.
Is that because of the oxidative stress? It exaggerates healing?
Healing, correct.
Man, so that same thing you're talking about training before, you don't want to protect your tissues with antioxidants if you want to hurt them. If you're trying to heal them, again, the oxidative stress is important to stimulate the healing, the migration of satellite cells.
If you're a super duper keen athlete to be a super duper, say, runner, you would run at high altitude and then you go to sleep in a low or high oxygen environment. So that's the quandary. It's like training in the gym.
But man, what about sleeping in? What if you're on a weight loss campaign and you sleep on a hypobaric chamber at night? Because those studies talking about the people that maintain weight loss, it was because they believed that the altitudes had something to do with fixing leptin resistance. So imagine if you were to sleep in a hypobaric, go low carb. You fix your lectin resistance by sleeping in a hyperbaric chamber.
I think it was Shane Warne who said he used to go to chambers to train, in special humidified environments where there was a lot of stress and noise and that sort of thing. And it turned out
there's also Shane Warne that said can't bat, can't throw, can't take. It wasn't the cameraman.
Yeah, it wasn't the cameraman. But he was talking about these chambers he used to go to with hydration and that. And what he was doing was going to the local bar. That's the way he described it.
Okay, that leads me... I'm doing a master segue on you. The next thing people wanted to ask about was the liquid oxygens at the bars.
Oh,
so in Vegas, they got these bars where they suck on this. What's that, Steve?
It's hyperbaric chambers. You're sucking in more oxygen. More oxygen gets delivered out, like a turbo in your car.
So you feel like energy.
More energy.
Yeah, right.
Because their energy is like...
So, turbo in the carb. So you get more oxygen, get better combustion. And that's the stuff. Yeah, that's cool.
It's great, except for the fact that it could lead to extra oxidative stress.
And lung cancers and things like that because of the oxidative stress associated with extra oxygen blasts.
But if you want to use more oxygen, exercise increases your oxygen utilization by 20 to 30 times.
Yeah, right.
Not percent, times. So exercise is by far the best way to oxygenate yourself.
I'm going to ask you a weird question.
Yeah.
Before I ask you another weird question.
Oh, okay.
So, what part of your body does gas exchange?
Let me guess now. That'll be, is it my stomach? Oh, my lungs, that's right. These big things here.
So how do we get oxygen into our blood? How do we increase oxygen in our blood?
Well, I breathe.
Yes.
That's what I do. I suck in some air that's 21% oxygen, and it goes in and you go to these little villi here and it exchanges at these little areas of your lungs and it takes out carbon dioxide.
Yeah,
that's how I do it.
So we're talking like lungs and bronchioles and things like that. Do you have any of that stuff in your stomach?
Ooh, let me think. No.
So when you drink something, then what happens?
Drinks.
Because what I'm saying is there's been a lot of products as a naturopath. Man, from the 80s it started when people started talking about it. In the 90s it was really big. Everyone doing these oxygen drops. It was like hydrogen peroxide, thinking, you're going to get the extra oxygen. You're going to drink that and it's going to put oxygen into your blood and improve your energy levels. It didn't do it. What it did do is create a lot of stomach ulcer problems and it sterilizes the gut. Same we talk about oxidative stress kills infections. That's what you use hydrogen peroxide liquid for, peroxynitrite. But there's a few people even asked about a diatomic oxygen, and I'm really struggling because it's talking about stabilized oxygen.
Yeah.
And I'm not the chemist like you, but when someone asks me about diatomic oxygen, I'm thinking 2 oxygens.
Yeah, that's
also
how it
known as
exists in
O2.
nature. O2, that's right. Di means 2, atomic is 2 atoms, and oxygen in the atmosphere all around us exists as O2.
Yeah.
That does exist at O3 up in the ozone layer, because ozone's O3. But oxygen in a gas form exists as O2, so it's normally diatomic.
Okay, so diatomic stabilized oxygen.
Yeah, just oxygen you breathe.
What is it, Steve-O?
It's just the oxygen you breathe.
But now, in water?
Well, what they do is they bubble the oxygen through the water, but it doesn't stick in the water. And if you own a pool out there, you have to make chlorine, which is a similar gas, Cl2, because most gases are with a 2, unless you're group 8 noble gases, they can exist on their own. But most gases have to be like nitrogen, N2, O2, Cl2. So that bubbles through water and it evaporates off unless the oxygen is liquefied at negative 186 degrees Celsius.
And that'll turn into a liquid, but your water that you're going to put it in is going to be hard as a rock at 100.
Yeah.
So
at 0,
how do you mix?
Freezes.
Yeah, at 0. Yeah, what did I say? 100's a bubbling, and that it goes the other way.
The Celsius scale is based on the boiling and freezing of water.
Yeah. So if your water is solid at 0 degrees Celsius, you've got to get to a negative 175 to make the oxygen liquid. How are you going to mix them together?
You can't.
And then drink it?
And that's why the FTC in America has busted these guys and have sued them for $250,000.
Yeah, right.
For making that claim.
Yeah, right. What claim?
That you can have diatomic oxygen and that oxygen can be in water and all that
and
sort of stuff.
And vitamin O. I remember they talking about vitamin O.
Yeah, they called it vitamin O.
That was in the 90s. They used to talk about vitamin O.
They made claims that it oxygenates your body and they couldn't substantiate these claims. And I'm not a big fan of Big Brother coming into it, but this time I kind of am on their side a little bit because they were making claims it cures cancer. Because you've got to remember, cancer, the way it reproduces is in an anaerobic environment.
Just so, my breath that I'm breathing out is, what'd you say, 16% oxygen?
16% oxygen.
Diatomic stabilised O2?
Of course, it's the only time the oxygen exists.
So if I was to get a straw into a water and go, am I doing stabilised diatomic? Oxygen.
Yeah, and watch what happens to the bubble. It goes in the water and then what happens?
Yeah, it'll come back out.
Right.
Yeah.
So it doesn't stay in the water, does it?
No.
So you can't.
Well, why does SodaStream make water bubbly?
Well, that's carbon dioxide under pressure.
So that's the carbon, the polar unit managed to hold it there, or is that we talking about molecular? So it's got the...
It has to be held there under pressure. Yep. Carbon dioxide is a little bit easier to work with because when you've got a diatomic gas like oxygen and oxygen, they're both identically the same, right? Now, if there's a like H2O, which is shaped like that, or water, got oxygen here and hydrogens here, that's got 2 different things, and that's called a polar molecule. That means they can one end's negative and one end's positive. They stick together and they can form a liquid at room temperature.
Yeah.
Okay? So that's how. But if they're the same,
are you talking about dihydromonoxide, that horrible stuff that kills hundreds of thousands of people every year through drowning?
Exactly, and washing away
H2O.
H2O.
Yeah.
And so this H2O stuff's a polar molecule, and it actually sticks and therefore can remain liquid at room temperature.
Yeah, right.
But oxygen and hydrogen and not helium, because that's helium's a noble gas. It lives on its own.
So the carbon dioxide you can hold in there.
Yeah, because it's polar.
As long as you've got a cap on there.
Yeah,
which
and
is why
pressurised.
when we release the cap, it goes flat because the carbon dioxide's left.
It comes out of the water eventually.
Carbon dioxide leaves gradually.
Yeah.
We're talking about stabilised
oxygen.
O2. It goes in and then bubbles out.
Bubbles
you
out.
Can't hold it because it's too light.
Because it's not polar.
Yeah, right.
It doesn't stick to anything else. Like a polar thing with a carbon in it or something that's different in it has a positive end and a negative end.
So why bubbles stick to the side of the glass?
Yeah.
Yeah, that's cool.
Because it's called electronegativity, and it's the electron pulling power of the atom. And a classic example of that is carbon monoxide, which is carbon one end and oxygen the other. That's very sticky, and that's why when that gets into your blood, it doesn't leave your hemoglobin. And that's why carbon monoxide poisoning is extremely dangerous.
Because it'll push the oxygen off your blood and take over with carbon monoxide. That gives you no energy, kills you.
Exactly. It stops oxygen coming in because oxygen's weakly attached to the hemoglobin.
Yeah, right.
Which is a specialised molecule to grab oxygen.
Yeah.
And carbon monoxide sticks to it.
So if you want it, for oxygen, drinking oxygen is done to give oxygen as a microbial, antimicrobial through your gut or to induce an oxidative blast to sterilise something.
Yeah, and because you've got to remember most
there is no way of digesting stuff to liberate oxygen for your stomach to put it into your blood like it would with iron.
Correct.
It's very different to iron, huh? You're going to break down your meat and you're going to put iron into your blood, and even that iron doesn't just jump into your blood. It goes transported blood, and then it's made into red blood cells in the form of hemoglobin.
There's no active transporters for oxygen.
No.
And you got to.
And you can't you can't inhale these liquids, can you? I mean, why would you? Because there's probably more oxygen in the air you're breathing.
Of course there is, 21%.
And we breathe out 16. So we're going to take 5% out of the oxygen we breathe. Correct.
And that's why you've probably given, or you've seen.
How much that? About a litre?
Yeah, half
a litre or something. So I breathe in like that.
And let's say, in some of these things it says take 5 mils, but I'm going to be generous and say that's about 20, 30 mils, 40 mils. If I drank that and that was pure oxygen, that's 20, 30, 40 mils of oxygen.
Yeah.
You just breathed in
more,
1,000.
And then breathed out more.
Yeah.
That I didn't need.
You didn't need.
That I couldn't hold.
You couldn't hold. You don't need to hold.
If my hemoglobin is full, that's why I can't hold it, huh?
Correct.
So the oxygen goes across, attached to hemoglobin. Once that's all full, the leftover oxygen just goes back out with my next breath.
Yeah, because you've got to remember...
So if I was to then want to take more oxygen into my blood, the only way to do that is to make more hemoglobin, which is like Lance Armstrong style, or hypobaric chambers and all that sort of stuff.
Running up the top of a hill. But you don't. If you have too much oxygen and carbon dioxide levels drop too low, remember it's carbon dioxide that regulates breathing. So you don't want to drop that too low or you'll pass out.
Yeah.
Have you ever hyperventilated? Anyone ever hyperventilated?
Yeah.
That's what happens when your CO2 levels drop and you pass out.
Yeah, I still didn't catch a dog and I was hyperventilating.
Well, you're probably burning, so you can pant. But if you pant without, without exercising, you will get too much oxygen and you will pass out eventually.
Right.
We used to do it with kids, but I won't tell people how to pass out. It's dangerous as shit.
What the hell? Put a disclaimer or something.
We better watch that. So, but it's called hyperventilation, and the treatment for that is to breathe into a plastic bag or a paper bag, so you breathe your own carbon dioxide back in to get rid of the oxygen.
Yeah, right.
Because oxygen, it's all dose dependent. Drinking it's bizarre. Also, it'll sterilise your gut, and you don't want that because most bugs in your gut are called anaerobes without air.
Yeah, right.
And if you add air to your gut, it destroys your gut.
Yeah.
But if you had anaerobes on your skin that are supposed to be aerobes, then that's good. And that's why they use hydrogen peroxide in hospitals.
So that's why it's good for acne because of their anaerobic propionum bloody bacterium acne. Yeah. It doesn't like oxygen. And if you can get through that plug and blast them with oxygen, they die.
Correct. And that's why the number one treatment, even medical treatment, is benzyl peroxide.
Yeah, right.
Peroxide is oxygen.
Man, so oxygen blasting can do some pretty heavy stuff to tissue. Now, I'm going to share my photo with these guys when I put it on my arm after a spider bite and gave myself 3rd-degree chemical burns. I know people put it in their hair, diluted down to like 3% or 1 to 3%. They put it in their hair and it bleaches it.
Yeah.
What's it do to your insides, Steve?
Oh, it rots it. It oxidizes your gut.
That's the same thing,
if you drank hydrogen peroxide.
Yeah.
It's like ozone.
So when these people put low dose, like do like 1 drop and then build it up to a few drops, they do it in water. That's purely to go through and sterile if they got bowel cancers or if you got esophageal cancers or something like that. That's an aggressive way of just sterilizing it and trying to poison it.
But you've got to remember there are side effects. Let's say you had esophageal cancer in your esophagus, and then you drink it, it passes there. Okay, it might do something there, and then where's it go?
Yeah.
It causes damage.
Oh, yeah.
It's not... I mean, but oxygen doesn't stick in water unless it's in the hydrogen peroxide form, which is a very...
And so it's H2O2.
That's the chemical, for hydrogen peroxide.
Yeah. Whoa, man.
So it's a bit scary, the old chemistry, and a lot of people don't understand the chemistry.
I mean, it goes to the point that what we do know about chemistry, we don't know enough. No. We've got to a point in our knowledge where we do not know anywhere near as much as what nature's worked out or nature just deals with.
I did a 3-year chemistry degree and I know I don't know enough. But you know, it's pretty bad because the arrogance is that... Because you've got to remember, chemists know about chemistry.
Yeah.
The body is like...
But the problem with chemistry is it's all based on assumptions of what they learnt previously.
Yes.
And this is the stupid thing. We go, we have made this assumption, we're going to do it further. And then they think, all that there is to be known's been known, all the myths have been debunked, the science has settled. It's what a load of crap.
And
You're never going to be that.
Settled.
And nature is so far ahead of you. Don't disrespect food and nature.
It's weird because chemists say, vitamin C is good for you, therefore more of it's good, therefore here's vitamin C, therefore take it, end of story.
Yeah.
That's a chemist.
Yeah.
It's called a reductionist chemistry.
And then here's the cheap... Well, you don't want to be paying money for gourmet stuff when I can give you one synthetic, cheap, nasty thing. You fools. You got no money anyway.
And if you're foolish, the body's got this inflammatory process. Here's an anti-inflammatory or an antibiotic or an anti-hypertensive or an...
And to think these same pharma people that are telling you you're not entitled to know if your multivitamin's synthetic or derived from food... do you think maybe the reason why they own all the money is because when these people take these things, thinking that they're natural medicines, you're from a natural medicine company that cares about them doing this stuff, oh no, we're going to give you a synthetic one. Guess what? Oh, it causes cancer. It causes heart disease. It contributes to diabetes. Oh, we've got drugs for that. And that's why I sleep on a bed of money.
Exactly. Well, you know, the statins increase diabetes by 50%, and that's not me being alarmist or whatever. That's just truth.
Yeah,
and we know that now. But statins are the most, widely prescribed drug in this country, and that's typical chemist thing. They see an enzyme. Oh, that's the enzyme that makes cholesterol. Look at it, 3-hydroxy-3-methylglucosamine reductase. Let's inhibit that, and that'll reduce cholesterol production, and we've cured the world.
And then just to add a complexity to it, to consider that the same pathway creates vitamin D, ubiquinones, which is CoQ10 molecules are a lot of intracellular antioxidants.
Yes.
And what actually causes heart disease, Steve, in regards to cholesterol? Oxidized cholesterol.
Yeah.
So it's the oxidation of cholesterol that makes it change shape, where the immune system has to attack it with oxidative blasts because it thinks it's a bug or something. It then engulfs and removes it, surrounds itself by oxidizing the local tissue to create like a calcium plaque or a foam cell. And that's what causes hardening of the arteries.
Exactly, that's what it is.
It's oxidative. The way to prevent it is antioxidants.
Yes.
Cholesterol medications, what do? Increase oxidative stress in those regions. Surprise, surprise, you get heart disease. Oh, and we'll throw diabetes in. We got a drug for that.
Yeah.
If only you took that synthetic multi earlier, we could have had you on it earlier.
This is absolutely horrendous. But
I get so angry with these people. But what makes me the angriest is, when we first started ATP, we talked about mottos and that sort of stuff, and we got some complicated ones we don't talk about much. But the goal, the original one, we believe that everyone deserves the right to live a healthy and happy life. But we know or we understand to achieve that, you need access to quality information, unbiased, accurate information, and you need access to quality ingredients.
Yeah, of course.
And so then we created this company to do that. And it just spins me out, how there's other people out there that just do not even take that into consideration.
Nah. Anyway, it's a chemist, mate.
That they're too smart, you will just lie.
Absolutely.
All right, stop my ranting. Let's do a FAQ.
We should sort of summarise here. The bottom line is,
bottom line.
Eat food that comes from nature, particularly above ground plants. They're always best.
Yeah.
Quality proteins. It goes back to those same principles.
More is not better.
Correct.
If it's too good to be true, it probably is.
Yeah, and watch out for synthetic vitamins.
Yeah.
They can be dangerous.
Let's do it. All right, well, that's us done.
All right. Well, you guys have a great day.
Yeah. And thanks for having us in your ears.
Yep.
And We'll talk to you soon.
See you next time.
That's a terrible sign-off. Thanks for having us in your ears. Did you hear me coming?